I'm Cody Benkelman. I'll go ahead and get started. I'm a product manager on the imagery team, and what I want to do is talk to you about some methods and recommended best practices for automating image management, and something new this year is storage in the cloud. If you've come to my presentation in the past, you will see some of the same material. So just a disclaimer up front, but I do have a little bit of new information toward the end, and hopefully this will be good information even if you have seen it before. Is there anybody not familiar with the Mosaic Dataset, not using the Mosaic Dataset for imagery now? Okay, good. I was assuming that would be the case, so I'll do that very, very quickly. What I want to talk about primarily is the middle bullet, and that's the automation with these Python tools that we've got hosted for you. And OptimizeRasters is something that's new to my presentation and fairly new at Esri. If you're a hardcore Python programmer, I'm not the guy that can answer your questions, but there is a session on Friday, and I'll put that up in one of my later slides just to remind you again. So if you want really gory detail, on Friday we'll have the right people who can answer that. So again, if you're familiar with the Mosaic Dataset, you know this, but I just wanted to make sure and set the context. The Mosaic Dataset is our database structure for managing, accessing, sharing, and processing imagery. And the key thing, if you're not intimate with it, the key thing that I want to make sure people know is when we create a Mosaic Dataset, it's a structure in a database, but the imagery is not in the database. The imagery remains on disk as TIFF files ideally, or whatever format files you're working with, and it remains in their original projections so the Mosaic Dataset can project on the fly. So when we talk about defining in the geodatabase, you bring in metadata, key metadata for the imagery, and then you can apply processing. The simplest example would be something like a hillshade if your data is elevation data. In the old days, you used to have to run a GP tool and create a hillshade. Now with raster functions, we can do that instantaneously. And actually, we've been saying that for 5-6 years, so that's not new. I hope everyone already knows that. Anyway, that's probably enough on the Mosaic Dataset. If you are familiar with the Mosaic Dataset, you know we've got well over 100 different properties, and setting those properties is part of the key of what I want. What we're trying to do with these workflows is give you advice on how to set those properties to optimize your image collections and your image services. There's a great deal of power in the Mosaic Dataset, but I'll be the first to admit it can be a little bit confusing, not knowing what sequence to do things, not knowing which properties to set, and that's part of what these workflows are intended to do for you. And because we have a grand total of 30 minutes, I'm going to skip my demos, but the imagery island is very close. I'll be happy to show you this after the presentation. The only thing I want to highlight here is the Landsat 8 service, if you're not familiar with it. It's 16-bit data, 8 spectral bands, 300 new scenes every day are ingested into this live service, and it's completely automated using the workflows that I'm referring to. So if you're not familiar with the Landsat 8 services, you should come take a look. I'll show you that demo. So our goals in terms of providing this automation, this is kind of preaching to the choir. I'm sure these are all fairly obvious, but I still wanted to touch on them. If we can successfully automate these workflows, you get more repeatability, so you don't have to worry about whether or not you forgot to check a box or whether you remembered to run a tool. If it's all automated, you can always rebuild something if you're not sure if it was built properly. And of course, it makes it more scalable and maintainable to have scripts that document everything that you've done. And the documentation, of course, helps just verify that everything was set up correctly. Another reason that we built these workflows is there in the middle, and that is to share our best practices and give you, our users and partners, working examples that you can build on and know that you're, as much as possible, applying our best practices. And I put simplicity at the bottom only because I try never to oversell anything that I do or that I want to lead you to. And as much as I would like to say that these workflows make it simple, I think that's a relative term in this case. This is not simple enough that you're going to hand it off to your mother or father unless they happen to be programmers. But we have achieved a level of simplicity. And again, I think the repeatability and scalability and maintainability are really the key components. But I won't tell you it's actually simple. Okay, so if you are managing imagery and you need to build Mosaic datasets, I'm sure you've probably seen the discrete tools where you can run one tool at a time. Create a mosaic, then add rasters, then set properties, etc. Very much subject to error if you forget one step or you take a break for lunch. If you want to automate it, of course, we've got Model Builder, which can be very effective for prototyping and testing. But Python is really the more scalable and more repeatable approach. These are some old slides that I'll just go ahead and throw on the screen. This would be a basic workflow for creating, populating, and then setting a few properties on a Mosaic dataset. And then I put this slide up just to challenge the audience. If you had to maintain these two models, how would you go about identifying what's different and what's changed? And I'm not going to bore you with that. But obviously we want to move to Python where things are much more maintainable. And again, this is on the bottom of the slide, I'm reminding you of where that deeper dive tech session is for Python. You can call the individual geoprocessing tools from Python, and what we're doing in these automated workflows that I'm going to show you is basically giving you a usable structure along with recommended best practices to call those existing geoprocessing tools. But I think it's still true that nothing in these workflows has been customized or modified from the out of the box GP tools. We are simply using the existing geoprocessing tools from ArcGIS. And this is just kind of a simple cartoon to give you a mental picture of the structure. The Python toolbox in the center is where we run we call the various GP tools and create the Mosaic datasets. But the key is you can create and then populate and then set properties on a single Mosaic dataset with one script. Now, if you're building a fairly complicated system and you need to make 10 Mosaic datasets, you would call this tool 10 times. Now, and if you chose to, you could wrap that into a larger script and just have one single tool that does all of it. But the tool that we call the Mosaic Dataset Configuration Script, or MDCS, is that object in the center. And then what I wanted, actually, I guess I'm getting ahead of myself. So MDCS, we're encapsulating our best practices, which really boil down to what sequence do I run the tools and which settings do I choose? And that's where, if you're dealing with elevation data, the answers are going to be different than if you have pre-processed orthophotos, and that'll be different than if you're dealing with high-resolution satellite data that's multispectral or something like Landsat 8. They all go into a Mosaic dataset, but the settings you use are going to be different for those different data types. And I've already kind of touched on the self-documenting aspect, but that basically is if you've got a configuration file that it exposes all of the settings you're using in your Mosaic dataset, then you can go back and check later to see what you did. Or in our case, the workflows we're sharing with you, you can read through them and see exactly what it is we're doing. We haven't documented with a Word file, a word processing file, absolutely every step, but we're assuming you, as programmers, can open up the XML file as needed. I guess one other component is the log files are automatically created, so if there's ever a question, you can see exactly what happened in the last run of MDCS. And we did build in support. If you want to add your own commands and your own tools into this architecture, I can show you where to find that. I think I've got one slide. It may be a little out of context, but I can show you at the island. So I've just got a few more cartoons here. I wanted to show you just again to give you a mental picture of what's happening inside MDCS. And again, this is all encapsulated within the XML file. So when you run the tool, you basically prepare the XML file and have your settings configured the way you want them. You call MDCS, and the input is the XML file that has all of your settings, the path to your data, the path to your geodatabase, what you want to name things, etc. So that's in the XML file. So it includes the input data paths, the raster types you're using. If you're familiar with the Mosaic dataset, it's very important to choose the proper raster type before you insert or before you ingest data. The Mosaic dataset properties, of course, are where some of the best practices are located or stored, and then we wrap all of those into one single tool to call all of the necessary geoprocessing tools. And this is probably obvious by this point, but that's where the best practices are captured. So I know everyone loves reading XML. I wanted to make sure and get this up on screen. If you're familiar with the Mosaic dataset, you'll recognize many of these fields. Under the default properties, I just picked a few as examples. The allowed compression type you're going to use for the Mosaic dataset. The Mosaic method, which is the term we use for which image appears on top. So if you're familiar with the basics of the Mosaic dataset, you'll see a lot of familiar terms in this XML configuration file. And then this is where I was saying this may be a little out of context. Without showing you the directory structure, it may not be obvious where to find this, but again, I can show you this in a demo. But there's a module called MDCS_UC for user code. So that module exists, but there's nothing in it. But that's the location that you would want to put in your own code to add into these scripts if you want to make modifications beyond simply configuring the existing capabilities. And again, I can show you this over in the imagery island. And once again, I'll skip my demo. I'm actually going through these pretty quickly. I may have time to come back for demos. So when we start talking about managing large collections, this slide perhaps should come after the next slide, but this is just showing you in the XML file, we have something that we refer to as the source and derived structure or architecture of building Mosaic datasets. And where many of the things you see in the XML file will look familiar, this is something that you will not find in the normal help documentation. There's no difference between, there's not a technical data structure that's different for what we're calling a source mosaic versus what we call a derived mosaic. Hold that thought if you're not familiar with what I mean, if you haven't heard some of this before. Let me go on to the next screen because this should make it more clear. The basic architecture we recommend is if you're managing large collections, and in this case what I'm working with is elevation data, we want you to put each separate data set or collection into its own Mosaic data set. So in this case, this is a very abbreviated version of the World Elevation Service that we've been hosting for about 5 years now. So the SRTM 90-meter data is in its own Mosaic data set. We stop at that point, do our QC, make sure the properties are set correctly for that 90-meter data set. Then we create another Mosaic for the NED 1/3 arcsecond data, the 10-meter data. I think that's right. Yeah, 10-meter data for the US. If you have LiDAR, I would put that into its own Mosaic data set as well. So you keep every collection separate in their own Mosaic data set to get through your QC. Now, if you're dealing with air photos, the model here might be referring to multiple years over a county or over an area of interest. So you've got the same area at the same resolution, but just different dates. But then the key to this architecture is once you know your source mosaics are constructed properly, you merge them and create a mosaic of mosaics. And in the top center, this is what we refer to as a derived mosaic. But again, you won't find menus in ArcGIS that say create derived. It's just a concept as opposed to something fundamentally different. And the key there in the middle, if you are familiar with the Mosaic data set, what I want to make sure you don't do is put mosaics into a master centralized mosaic and use the default raster type. I want you to use the table raster type, because the Mosaic dataset is fundamentally a database table, and you want to use that raster type if you're making mosaics of mosaics. And just to stop at this point and give you a quick example, if I've got 30 records in each of those source mosaics, I will have 90 records in my master centralized derived mosaic here. If you use the default raster type, you will have 3 records in your central derived mosaic. And that may sound like an advantage, and in some limited scenarios you can do that, but you're actually embedding database tables inside other database tables. And if you get more than 8 or 10 of those, and if you cascade this another level, you can really get into some performance problems. That's if you don't use what I'm showing on screen, if you use the default raster dataset raster type. If you use the table raster type, it scales very well. I mentioned the Landsat 8. That's got about, I think it's about 200,000 records. Sangeet, do you know how big that is? Something like that. The LandsatLook is a Mosaic data set we built for the USGS. It's got over 2 million records in one central Mosaic data set. So it definitely scales, but only if you use that table raster type. And then before I forget, I want to be clear in the lower right, I'm not talking about merging optical imagery in the first mosaic with elevation files in the second. So I'm only talking about merging together data that makes sense. If you're dealing with 1 meter multispectral satellite data and Landsat, you might want to merge those together to use Landsat as your overviews and then zoom into high res. But for the most part, I don't mix different data types in that central mosaic. Okay, then once you've shared once you've built the centralized mosaic, if you are serving through ArcGIS image server, the advantage here is instead of having a map with multiple checkboxes for all your different image services, when you bring those into a map, you have one single endpoint for all of your data, and then you can use raster functions to look at RGB, NDVI, color IR mixes. I guess I didn't show the same for elevation, but if you have slope, aspect, hill shade, etc., those are raster functions coming off one single image service. And this architecture is much more efficient on your server. If I jump back to here, we could share each of these mosaics as separate image services. And again, if you've only got a handful, this is not necessarily a bad way to go. But if you start to host 10 or 15 or 20 data sets, 30 or 40 different services, you will consume more image server resources, even if nobody is currently using those services. Whereas if you use this architecture, everything's consolidated before it gets to the service, and this is a much more efficient use of your server. And then the bottom line, or one of the key aspects with this architecture, is when you then bring new data in, once you've done your QC and use the table raster type to merge your new collection into your existing master, all of your downstream services and functions are already done. You don't have to reattach the NDVI, you don't have to rebuild the hill shade. Everything downstream simply works from that centralized mosaic. Okay, Emily is in the back corner. This page just went live yesterday. So if you had seen my slides 2 days ago, I'd be directing you to a different landing page. But if you want to see these workflows and download the examples, we've got a landing page that will basically point you to a discussion of the various workflows. And then we've also got sample scripts that you can download with sample data. So in the center is elevation. So if you'd like to see a model, it's only got the data for Oregon, but it's essentially the model that we used for the world elevation, where we start with GM-TED data, then SRTM at 90 meters, USGS NED at 30, 10, and 3 meters. And I think in some areas we even have 1 meter data derived from LiDAR. Anyway, that's in the managing elevation. The one that's most commonly used are the pre-processed orthos, the one on the left. But in our ArcGIS Online group, you can download these sample scripts, and a separate download of sampled data and actually build exactly what I'm talking about on your system and see how we did it, and then you can extend it to your data. Okay, so if you click on any of those in the bottom or in the upper section, we're starting to segment this now by image management versus image use and image analysis. Today what you'll find is mostly focused on image management, which was kind of the topic for this talk today. But we're going to be doing more with image analysis, like classification, segmentation, and some of the other image use or analysis workflows. Okay. By skipping my demos, I'm actually further ahead of schedule than I expected. So I can come back to those if you'd like, but this will give us time for questions. So if you've seen this talk before, this is something new. OptimizeRasters is a tool that we've built. You can use this on local architecture, but it was really intended if you're going to be storing imagery and serving imagery from the cloud. So at the top, you'll see a link, a short URL link to GitHub if you want to download this tool. I don't think it's currently in our workflows, is it, Emily? Okay, it's not. So this is not in that previous landing page I had shown you. But what this tool will do will take a local collection of data, and if you input your credentials, for example, for Amazon Cloud Storage, it will upload files into your Amazon account. And if those files are not in an optimal format, we will reformat the data. One of the questions we get is, what is the optimum format? And in general, if you do have to rewrite your files, what we recommend is rewriting them as tiled TIFF format with internal pyramids, and you can apply compression, again, depending on the type of data. So OptimizeRasters will do that for you while copying up to the cloud. And in that, I guess, fourth bullet, you'll see a mention of MRF. That stands for the Meta Raster format. This was a format developed by NASA that we've implemented in ArcGIS. It's not Esri proprietary, but we've implemented this format. And I wanted to build a slide, but I just haven't had time. It's basically intended or optimized for cloud storage, where the pixels are stored in one file, the metadata and the header for those images is stored in a file that we call a proxy raster file. And then there's a third file that's basically an index, so it's your geospatial index. But if you're accessing imagery from the cloud, without knowing where your user is going to pan and zoom next, you don't necessarily want to have terabytes of data stored locally. You can have terabytes or petabytes of data stored in this format in the cloud, and what the user downloads locally are those small sidecar files, the raster proxy files, that allow the software, that allow ArcGIS to know where the pixels are located, and then when you access the actual pixels, those are read from the cloud. Now you can do this in your office on your desktop computer, but you're going to be limited by the bandwidth of accessing the cloud. Where this really works extremely well is where you're serving from the cloud, and you've got servers sitting next to the Azure Blob Storage or next to Amazon S3 storage, so that access of the pixels from S3 is actually fairly fast. But if you're familiar with cloud architecture, if you copy data to a server, another server can't share those disks. So if you need to replicate and scale up from one server to multiple, it takes time in the background to copy files from Amazon S3 to the EBS storage. And this structure, the MRF structure, allows the servers to directly access from S3. So maybe that's a long way of saying it's somewhat like the way Dropbox works, where it looks like you've got a Z drive on your computer, but you're actually accessing files in the cloud. That particular architecture doesn't work very well for imagery. That's why we've implemented the MRF format. There's also a mention of the LERC compression, LERC. That's mostly applicable to floating point data. But you can get very, very good compression using that lurk as an optional compression technology. And again, this is how we're actually serving both the NAPE image service and the world elevation. So if you've used those services, we're actually using the MRF format and accessing data from Amazon S3 when you're hitting those two different services. So it works very well, again, with floating point elevation value data, as well as the 4-band NAPE imagery, which is multi-date. Okay, so I think I'm actually ahead of schedule. So I'll put these links up on screen. If you want, you can start filling out your survey. Let me ask if there are any questions, and if there aren't any questions, but you do want to stay for 2 or 3 more minutes, I could go ahead and do one of these demos and show you some of this imagery. Any questions about all of this? You mean the third one I mentioned, the source, the derived, and the referenced? Yes. I forgot to address that. So there is another type of Mosaic data set, that's the reference Mosaic. And that is a literally different type within the software. The reference Mosaic, if you're not familiar with it, is a read-only copy. So if you, say for sake of example, you've got the NAPE imagery and you want to share an image service showing only North Carolina, you don't have to create another Mosaic data set and run MDCS. You can just make a reference Mosaic data set and then do a where clause query. So if state is North Carolina, it appears in the reference Mosaic. So there are a lot of ways you can use the reference Mosaic to access something out of a master, but it's a read-only copy. One of the key uses for this is if you actually serve your Mosaic data set as an image service, you cannot update that live Mosaic data set unless you're in enterprise geodatabase. If you're using a file geodatabase, when you share an image service, it locks the database records, and then you can't update it. But if you're using a file geodatabase, you create that central Mosaic, then create a reference and share the reference. Then you still have the ability to update the master, the derived, and the reference will instantaneously show the new records. And so it's a way to avoid that geodatabase locking. So kind of a long answer, but is that kind of what you're asking? Yes. Yeah, everything, well, all of the derived mosaics I showed in the center are using the table raster type, not the source. The source mosaic, if it's Iconos data, you use the Iconos raster type. If it's Pleiades, you use the Pleiades raster type. So on those source mosaics, I'm glad you clarified this. It's very important with satellite data to use the proper raster type because that brings in all the metadata such as sun angle information. If you've seen any of our demos of doing mensuration and measuring vertical heights, to do that you've got to have information about the camera model, and you'll only get that if you use the proper raster type in your source mosaic. So, other questions? Yeah. I don't, well, if you couldn't hear, the question was, is there any limit to the number, or if you were to take that diagram and cascade it, I don't know of any limit. Again, it's critical to use the table raster type. Prashant's going to come up and start setting up, but we'll keep going for a few more minutes. I don't know of any limit. I think the most that I've ever seen is about 4 levels in that hierarchy. But again, if you use that table raster type, you're getting the entire record from the source into the derived. Okay. Actually, that works. I think that should work relatively well, unless I'm missing. There is a potential challenge with the time slider. because that starts to get a little bit more complicated. With our web tools, with Web App Builder and the Landsat demo that I wanted to show, we've actually implemented a widget called the time selector that I think is a much simpler implementation than the time slider. But it should still work. I guess maybe we can talk in the booth afterward and see if I'm missing something. So I need to wrap up and let these guys get started. I'm going straight to the imagery island if you want to come see demos and ask questions. And there's my email if you need me. Thank you.